Chapter 7, Section 4, Special Parallelograms. So we've got three types of parallelograms we're going to look at today. We have the rhombus, we have, good old reliable, the square, and we have the square's greater distant cousin, the rectangle. Yep, I know. That's a horrible joke. But it kind of feels like a, whoop, I got a little line through it there. Good times. The rectangle. So each of these has very specific properties. Let's look at the square and the rhombus first. One of the major things on a square and a rhombus is all four of those sides are congruent. So if you have a quadrilateral and all four sides are congruent, it's either a rhombus or a square. And the things that determine, or what determines whether it's one or the other, is on the square, we're going to have four right angles. So I will tell you that a rhombus is not always a square. However, a square is always a rhombus because it has the same properties. And then rectangle, we've got quadrilateral with two sets of opposite sides that are also parallel, and each angle is 90 degrees. Now, we've done a lot of, all of the traits that hold true in a parallelogram are the same in these special parallelograms. Okay, opposite sides congruent and parallel, opposite angles congruent, consecutive angles are supplementary, the diagonals bisect each other. Some of the differences in a square and a rectangle, the diagonals are congruent. Okay, the diagonals in a square and a rectangle are congruent. And another diagonal property, the diagonals in a square and a rhombus are perpendicular. So they not only bisect each other with the basic property of a parallelogram, but they're also perpendicular. And so what you're going to see is multiple different examples. Let's do a couple of them. Let's find a good one here. Let's take this. Oh, not that. Hit the wrong one. Sorry, guys. Let's take this one. And we're actually going to flip it to the left. There we go. That's what I want. And I'm going to draw some diagonals, which probably right now you're drawing diagonals as well. And let me label a couple of things. We're going to call this angle 1, angle 2, 3, and 4. Okay, and so we've got this particular angle. Let me draw it a specific color. This specific angle right here is 118 degrees. Now, what I forgot to mention is in the case of a rhombus, we have the diagonals. They are not the diagonals not only bisect each other and perpendicular, but they also bisect the opposite angles. Okay, so what are some other things we could put in here? We know that these are all 90 degrees. I'll just write those two so it doesn't get too congested. And so if this is 118 degrees, then this angle right here is half of 118, which is going to give me, let's see, if it was 120, that would be 60, so it's 59. Each one of those is 59 degrees. So I've got this little right triangle where I have a 59 degree angle, I have a 90 degree angle, and so I can find out if I've got 90 and 59, that's going to give me 149, which means this missing angle right here has to be 31. So if angle 3 is 31, then angle 4 is also 31. And that means angle 1 and 2 are all 31 as well. So just looking at different properties of a rhombus. So that's about it, guys. That is Chapter 7, Section 4, Properties of Special Parallelograms.